All right. Good day, everybody. My name is Britton. This is going to be one of my first tutorials, so excuse any my excessive umming. I'm going to get into this as quickly as possible. We're going to back out of this program. Alright, so I'm on a Switch. I'm using a program called Smile Basic 4, which you can see at the bottom here. This is a paid application. It's around $20, I believe, and then $24 if you want your upload token, which allows you to upload up to 10 programs and download as many as you want. I have a couple favorited here. This is what I'm actually going to be doing a tutorial on today, and then this is something by somebody else. So we're gonna get into, this is what I'm going to be, in a way, giving a little tutorial on how to create. It's a little particle physics engine. There's no collision between two particles. I didn't want to do that yet because that requires just a little more math. And I also did sound for this. I'm not gonna do the stereograph at the top or anything. But I will do the, we're going to do gravity, we're going to do friction, air resistance, and bouncing, and boundaries. We're going to do boundaries. There's boundaries on this side and this side, you can see right there. There's no boundary out the top, which allows me to switch gravity and then drop everything again using X switches my gravity and B switches it back down. So let's get into this real quick. I'm gonna give a quick overview of this program. This program is fairly small, actually. It's only 119 lines. This tutorial is made for people who either don't program or are just getting into programming, or maybe you're an absolute beginner. This might look like a monstrous file right now, but I promise you it's not as complicated as it looks once I explain everything. Most of these huge blocks of like one line that's like 2 lines long, this is actually just variable clarifying and using arrays and simple math. And then a lot of this is denoted by itself. You can see air resistance is literally 3 lines, which is actually 1 line contained in an if statement. Friction is 2 lines in an if statement. Gravity's 1. Floor bouncing. There's also boundary bouncing down here somewhere. But yeah, we're gonna get into this today. There's also auto particle removal. Almost screwed that up really bad. This is to keep your device from having to compute far too many particles. If I actually took this out, once you get around the 700 to 800 particle range, it actually starts dropping your FPS because it's having to compute particles that are no longer moving, which I will get into also. Alright, so first things first, I know you can't see this text up here, it's very small. That's because I have the resolution changed for this project. So we're going to, you can translate this program into any language that you need to use. So as long as you have a basic understanding of whatever language that you're needing to use in order to produce this topic of a program, this should be very easily translatable into a different language, because this is a very basic language. So I'm fairly certain with my experience of higher languages that you can definitely do this, probably in a lot less lines also, and with much more efficient methods and on much more powerful devices. Alright, so I'm going to try to make the code at least readable, if I can get this to adjust itself. I don't have a screen recorder yet, although I wish I did. I'm going to lock the brightness here and then bring it down so that you can read everything. I'm going to have to type with my fingers because I don't have a USB keyboard yet, so I know that's going to be annoying, but just bear with me. This is very simple, very, very simple. All right, so the first thing we need to do, we need to have an endless loop for all this ridiculous math. So we're gonna set up our while loop. So while one, this and your when, this is going to cancel your, it's going to end the loop and it's going to loop back to the top. So you don't have to have any go-to commands or anything like that. It's just a while one, and it's just going to continuously loop because it's saying, oh, this is true, so keep going. You can also have 0. It doesn't really matter because while 0, I mean, it's 0, so it's true, so it's just going to keep looping. Anyways, let's get into our variables. I'm going to have to set up an array, which may sound complicated, but it's not, I promise. All right, so for our array, you're gonna have to set your dimensions for this particle array. I'm going to call it part. And then for this language, I need square brackets. And then we need to have however many variables we need for the information for each particle. So for each particle, we're going to need to have particle X, particle Y. I'm setting these to incrementally higher values because later on, I don't want to have to remember how to get to these values inside of the array. So if I'm at some random particle and I don't really remember which variable is for velocity and which one is acceleration, I don't want to have to scroll all the way back to the top over and over again. So what I do is I literally just have these set as arbitrary values so that I don't have to come back and look at them later. This is a 2-dimensional one, so we're just going to be working with X and Y. I might do a 3D one later, but not at the moment. And then okay, so I got to talk about these variable names real quick. Just let me finish these. Obviously, feel free to skip around in the video. I'll probably have time bookmarks in the whatever they're called in the description. I don't upload to YouTube a lot. I just felt like this was something really interesting. All right, so the px py, that is your position x, position y for a particle. Vx, Vy obviously is going to be your velocity, x and y direction, and then Ax, Ay is acceleration, acceleration y, and then your Bv, that is bounce variable, which we're going to set the same for every single one. We're also going to need to do, there's one more, it's lifespan, which we're going to set as LF. In my other one, I set it to whatever the name of the array was, and then AL for alpha, but we don't need to do that here. All right, so we have our array. Excuse any screaming going on in the background. I do live in a family. All right, so we need a way to loop through all these particles, and we need a way to make particles because right now our array is empty and we want to create particles wherever we're touching on screen. So for that, I'm gonna do a input command which will get where I'm touching on the screen, translate to whatever language you're using, or if you're using this exact language and program, then good for you. This is just where I go to test out any ideas that I might want to take to a higher language once I get a decent computer. So TM is how much time I've been holding somewhere on the screen. After I let go, it changes back to 0. We don't really have to use that for anything, but it's required in the syntax for this language. TX obviously is going to be where on the x-axis I'm touching on the screen. TY is the y-axis where I'm touching on the screen. I'm trying to talk quickly so that I don't waste anyone's time. And then we need to, I guess we are actually going to need to, we're going to need to actually use this. So if we're touching the screen, right, if I'm touching the screen, TM is going to start going up. It's going to be more than 0. So if I'm touching the screen at all, no matter what TM's value is, as long as it's above 0. If we're touching the screen, then we need to push our array. I'm gonna go ahead and do this so I don't forget about that later. If we're touching the screen, gotta get this readjusted, then we need to push our position, velocity, acceleration, bounce variable, and our lifetime onto this array for however many particles we're creating. So we're going to do push our array name, and then this is going to be our position, right? Because we're pushing on to the beginning, so we need to, or we're pushing on to the top of the array. So we're actually pushing onto the end, not the beginning, I believe. We're adding to the array. That's what I know. I don't know if it's the beginning or the end. I just know that it works. I've been programming forever and still don't know if it's the beginning or the end. So we're going to push onto our array. We need to, since this is our position, we need to have our position set to where we're touching on the screen. So that's going to be TX, and then push TY. Forgot to clarify the array. All right, and then I'm going to copy these, and I'll show you how I did the random velocity here. So we're going to do, let's do 0.4 times, because we're working with pixels, not actual real life objects, these values need to be smaller than life. They cannot be as big as life, because if we set this to be an actual speed of velocity in real life, like take my glasses for example. Wow, that's really dark. Take my glasses for example. This right here, that impulse right there is like, I don't know, like 4 or 5 maybe feet per second before friction takes full effect and stops it in its tracks. Maybe, I'm not saying it's actually that fast, but you know what I mean. So if I were to translate that to our velocity for a pixel on a screen, it's actually going to be, it's going to fly quickly and leave the screen very, very quickly. So you have to work with numbers that are smaller than real life. So we're going to go from 0 to 10, and then times 0.4 is going to, it's going to divide it by 4, correct? Yes. Or it's going to multiply it by 0.4, which would be dividing by 4. Yes. So 0.4 times a random number from 0 to 10. If we also want to have negative velocity in a random direction, then we need to do r is equal to a random number from 0 to 2, and then if r is equal to 2, then r equals -1. So why do I do it like that? Obviously, if you can do this all in one line, just change it to be from -1 to 1. What I'm doing is I'm making it so that I'm forcing it to be between those values, so that if it is 0, it's just gonna, it's not gonna have an x velocity at all. If it is 1, it's going to be in the positive direction, and then if it's 2, I actually want to set that to -1 so that it can have a negative velocity. So I'm just literally taking the 2 out and replacing it with a -1, but because of the syntax of this language, it won't let you go below 0 for random values. So that's that, and then we're going to multiply this by r. So we're getting a smaller value than 10, and then we're multiplying it. It's either going to be going straight down or to the positive direction or negative direction. All right, so then for our velocity in the y direction, we can just set that to 0. Our acceleration in the x and acceleration in the y, we can set those to 0. And then for our bounce variable, that's not what I wanted to do. For our bounce variable, we can set this to -0.5, 6. We'll do 0.6 just because it's kind of fun to watch things bounce. And then for our lifetime, we're just going to set this to like 300. Okay. so now we have all this. If we're touching the screen, we can create particles on the screen. How do we see them? Because we have no way of seeing them yet. So what we're gonna do, we need to have a variable that tells us how many particles we need to loop through in order to display them all. So we're gonna go back up to the top, and we need this variable. I'm gonna call it P, we'll just call it num, and set it to 0. All right, so at the end of this whole command, we're going to have num equals num plus 1. You can actually do this a lot shorter in a couple other languages like Python. I'm pretty sure you can do num plus equals 1 or something, so that you don't have to clarify that you're just adding 1 to the same variable. You don't have to put the variable name again. So now we can do, now we can loop through to find, or to display every particle we need to display. So I realize that I keep pushing my screen off. I'll try to fix that in editing. All right, so for I equals 0, right? Because in computer science, everything always starts at 0. It doesn't start at 1. So we need to start at 0, which is the first variable, and then 2 num minus 1. Why do I do num minus 1? Well, if you look here, our amount is actually 0 when we start. That means we have no particles. So, actually, no, we don't need to do minus 1 for this part. And then we need to increase I at the end of that. But our I set to 0, our amount of particles is set to 0. I'll get into minus 1 later if that's needed. I don't remember when. So how do we display all these? We need to have a single command that will take this array, and where each particle is located within the array, and we need to only display where the particle X and particle Y is. We need only these two values. So how do we do this? So what we're gonna do circles the way I did it in the other, in the one I demonstrated at the beginning. We need to, for the syntax for this command, we have to do the X variable, the Y variable, and the radius. So we're gonna do our array name, and then however many particles we're on, or we need to take our, how many variables we have right here. So I'm gonna call this PN for our, or we'll call it VV for, I don't know, variables or something. And we'll set that to 8 because we have 8 different variables and we need to jump that many to get to the next particle in the array, right? Because we're adding all these for every single variable that we're putting into the array. So we need to skip all this. We need to get to px, and then we can add 1 to get to the y. We can add 2 to get to the velocity x. We can add 3 to get to the velocity y, and so forth. So we need to skip 8 to get to the next particle x location in the array. So that's why that's why I've done that. Okay, I'm gonna try to hold this closer. If I forget, I'm very sorry. Okay, so it's also kind of blurry for no reason. I'm really sorry. If I had a screen recorder, I would use it. Okay, so how do we go about this? We need to get our whatever particle we're on, which is I, right? Because we're using I as the particle that we're on, and we're going all the way up to the number of particles that are on our screen. So we need to do this, whatever particle we're on times the amount of information, which I've set the variable VV, and then we need to get the X value for this particle, which is our plus PX. That's why these lines are so long, is because I'm doing it this way, because it's the easiest object-oriented way to get the information for your particles. So I'm just going to copy and paste the same thing to get the PY, And then for our radius, we'll just do 5. That's a decent sized circle on the screen, right? And hopefully, oh, we need to clear the screen on each frame, which in this language is GCLS. And then at the bottom, so that we don't get any flickering, we need to turn VSync on. And subscript out of range in 036. What is that? Oh, it's because there's nothing to display. So we also need to do something for if there's nothing to display, just to skip. So what we're gonna do is if num at all, then this means that as long as num is not 0, it will loop through. So right now, it can't do anything. Hopefully this works. Nope. Okay. Subscript out of range in 36. Okay, what have I done wrong? Whatever particle we're on times the information plus px, so it should start on 0, and then it should get the y variable as being 1, unless I've remembered this wrong. I've been using this language for a while. Center point x, center point y, radius. Does it need... Okay, let's go back to the terminal. We're gonna display I was set to 1. Okay, so what was our num? Our num was 1, so it went up to 1. Okay. So maybe you do have to do -1 because it's going to a variable that it can't reach. Okay, that's why I was going on that rant earlier. So now this works. You can actually make a drawing program out of this right here. I'll do that at some point. I've done it before. It's pretty fun to work with. Okay, so the reason you have to do -1, which I was going to rant about earlier, but I cut it out. The reason you have to do -1 here is because we're starting at 0, and we don't actually have a 0th particle yet, because the 0th particle would mean that we have data in the array. So we actually need to subtract 1 because we don't have a 0th particle until we create our 0th particle, because in computer science you start at 0, not at 1. So when num actually becomes 1, we can start looping through to go from 0 to 0, and then once num becomes 2, we can go from 0 to 1, because we have 2 particles, but as the computer is reading that is a 0th particle and a first particle, not a first particle and second particle. Hopefully that makes sense. If not, I or somebody else in the comments can help you if you don't understand that. So now we have this. What do we do now? Now we have all these. They're not moving. How do we get these moving? So the way we're gonna get these moving, we need to display these, obviously, but we need to have all the rules set in place first, just in case, so that it doesn't try to display something that is either not going to be on the screen or anything like that. I don't need to do that since I'm going to be setting boundaries, but let's do falling first and our floor boundary. Okay, so our gravity, I'm going to go back up here to our stagnant variables, and we're going to set gravity to be 0.0981. That is gravity in the real world divided by 100. So, and then we need to have our friction variable once we start working on that. I'll set that to 0.7. Okay, so let's do this. I'll explain the math a little bit as I'm doing it. So we have our loop. We need to get our we need to get our velocity and we need to add to it. Py and then py. We need to do our velocity, and we need to add, not multiply, our gravity variable. Why do we add instead of multiply? Well, because the math for, I mean, we could multiply by g, but I'd just rather add each time so that we have a constant increasing velocity. Multiplying can get a little messy, so I don't want to mess with that because then you have to do division later. And I'd rather just work with addition. It's much simpler, especially for a simple tutorial like this one. Okay, so I have 0.0981. We're adding that every time. And we don't want to add that if it's below a certain threshold, right? Because once we hit our certain threshold, which is our floor, we don't need to be increasing their gravity anymore. We will once they bounce back into the air, and we'll get to that in just a second. So I accidentally hit my stick. Okay. So we need to say if our position y is less than, we'll do 200, that's the same floor variable that I set in the demonstration. And if, so this means because of the way that computers process graphics, your y actually starts at 0 at the top of the screen and increases as you go down, right? So, okay, I also need to change the dimensions so that this makes sense. And we're going to change our screen threshold for the floor to actually be around 700. That should work. So I'm going to set my resolution to 1080 by 720. In other languages, this would be like a window command or something like that. All right, and we're going to set our floor threshold to be 700 instead of 200. Obviously, change that number as you need it to be so that it works with whatever device you're running it on. I know some of my friends like to play around with calculators. Make sure that your screen resolution works with the floor threshold that you set. So as long as they're above 700, they're going to get, their velocity is going to get added by gravity. So how do we get them moving? Because all we've done is increase the velocity. We haven't even touched the position, so these actually are not even going to move. Well, the way we do that is you're going to take your acceleration, this is important, and you're going to set your acceleration equal to itself plus the velocity. And then you're probably thinking to yourself, wait a second, if we're doing the acceleration of a particle and it goes past the floor, the acceleration doesn't ever slow down. What do we do about that? It's going to go through the floor, dumb nut. And that's true, but we're going to get to that in a second. So now we have things falling. This is cool. Or I didn't update the position yet. We have to have commands that update the position so that these things actually move. We're gonna do, okay, so now we can do position X and position Y. Position X is equal to itself plus the acceleration in the X direction of that variable. And then same thing with the Y. So position Y is equal to position Y plus its acceleration in the Y direction. So now we have this. It doesn't want to work in the negative direction, even though I fixed it that way. Oh, that's because it's actually, we actually need to set this to go from 0 to 3. Forgot about that. Now it should work. Okay, so now it works. You can see it's going in each direction. Cool. All right. I'm gonna set this to be a smaller variable just because I don't like how fast it's shooting these out. Alright, so that should work, but the thing is, these things are constantly falling now, so what do we do about that? I'm gonna draw a line at, not lime, I'm gonna draw a line from 0 to 1080, which it can't even draw to. We're at 700, that's our floor variable. So we can see where our line is. It's at the bottom of the screen, you can see it. We can't do anything with it yet. The particles aren't interacting with the floor. How do we do that? So now we need to do, if they are past the floor or equal to where the floor is, we need to reverse their acceleration so that they bounce back. So this is where the bounce variable comes into play. So we can actually, I'm just going to copy this right here. What we can do, if it is more than or equal to our floor variable, 700, then we need to take the velocity and set it equal to that times our bounce variable. And the reason I set the bounce variable in the array is so that if you wanted to have a random bounce variable for every single particle, which would be kind of wonky, you can do that just for extra customization, I guess. So we'll go ahead and do this. And then we need to change these to be acceleration. And then we also have to do it for velocity. I'm fairly certain. Yes, yeah, we do. So copy these two lines again. And then we'll do variable, or velocity. Well, that doesn't seem to be working very well. And that's because I don't have air resistance, and we do not have any way of stopping the X's from bouncing the way they do, and we don't actually need to reverse the X velocity and acceleration because we're not even messing with that yet. We're just messing with the Y. We just want it to bounce up. In physics, when something is moving in the X direction through the air, it will retain its same velocity in the X, assuming the air resistance is negligible until it hits the ground. So we don't actually need to reverse that when it hits the ground. We just need to reverse our Y direction. And as you can see, it's still not really working correctly. It's kind of working, but not really. Things are still going below the ground, and they don't know what to do once they come back up to the ground. So how do we fix that? Well, this is actually a simple fix. So what you got to do is you're going to take this, I'm going to copy and paste that. This entire project is literally just copy and paste, to be honest, with a little bit of math and arrays thrown in there. So we need to take our position Y and set it equal to 700. That's about it. So now things bounce. So that's cool, but they're still flying away. So how do we fix that? Well, we also want to take this command where we have things still in the air, and we need to do something with the X direction. We actually don't need to increase, I don't know why I did that. Why did I do that? We don't need to increase the X direction by gravity. What we need to do is we need to take its velocity in the X direction, and we actually need to apply an air resistance variable. So what do we want this set to? Should it be the same as friction? Maybe. So we'll do AR is equal to 0.8, maybe? Yeah, sounds about right. And then we'll have our velocity equal to itself times AR. So now things are not constantly going straight to the right. That's odd. Why are things flying away? Okay. Did I accidentally do the Y for that? No, I didn't. They're getting gravity added, so I don't know how they're flying up. And only a few of these are actually we have negative 0.6 air resistance. Okay. And then if it's more than or equal to 700, we can do that. But I'm concerned as to how in the world okay. Okay, so the issue might be the order of the code right here. This simple movement part needs to be moved on top of all of my rules, because that way we can actually have all that beforehand. No, we don't. We don't need to do that. What have I done wrong? If position-wise less than 700, which means it's above the ground, we do velocity-wise. Oh, here. Oops. That was the issue. Okay. Okay, there we go. Unfortunately, the bounce variable is not negative, is it? It is negative. It's negative 0.6. What in the world? I swear I've done this before. Okay, well that kind of works, but not what I'm looking for. I'm fairly certain it has to be added to both, unless it just doesn't. I don't... What? It shouldn't do that. Now, it's correct how they're landing on the line, because that's how I did the math. That is where the floor is at. These particles that are just moving off to the side, they're never going to stop moving because we don't have friction, not fraction. We don't have friction added in yet. So I guess velocity actually doesn't need that. Goodness, that's going to overflow. Okay, well, interesting. Guess we don't need that. Alright, so now we do velocity in the x direction. So we're gonna do this here. We're actually gonna do it in front of that setting. We're gonna do velocity in the x direction is equal to itself times friction times F. This should relatively stop things from moving, except our acceleration is not being affected. And since acceleration is our main factor that we're using to update the position, we're gonna need to do that instead of velocity. But we'll do velocity also, just to stop the velocity from increasing, because of the way computers do these things. Okay, so obviously things are not they're not bouncing as much as in my demonstration program. We're gonna go ahead and change the bounce variable to be 0.8. That should give us a little more bounciness. There's that. And then it feels like things are falling too quickly, so why don't we go ahead and change our gravity to real life gravity divided by 1,000. Well, that makes things a little too floaty. Well, I don't know. We could just go ahead and change the bounce value to 0.9, but that seems a little too jiggly. Yeah. Seems pretty jiggly. I don't really like that one. But that's how you do floor. And then we're actually gonna do 705 just so it actually looks like they're touching the ground and not going through it. To an extent. It's a radius of 5. Go 707. Interesting. Alright. Now we need to do the removal, and then left and right barrier on the screen, and then I might do sound, but this is getting to be a very, very long video. It's going to be difficult to edit a lot of this. Okay, so let's do color, or not color, but at least showing that they're disappearing. We're going to do RGB, and we're going to base all three. We're going to base red, green, and blue off of their life value. So what does that mean? We're going to be decreasing the life value whenever a particle is not moving, which I'm pretty sure we set to LF. Is that correct? Yes. So we have that. I don't know why I didn't just copy it. There we go. Paste. All right. So I'm not going to do any fancy colors because that was based on their velocities and everything, and that's just a little too much detail for this tutorial. So we have it based on their lifetime. So how do we determine when something isn't moving? Well, when its acceleration is 0, or at least close to that. Actually, let's go ahead and set the acceleration and velocity limits. So if the acceleration in the x direction is less than 0.9, then our acceleration in the x direction can just go ahead and be set to 0, because that means that it's moving less than, or we're actually going to do 0.009, and we need to do the absolute value because we have negative acceleration in computers. So there's that. And then we need to do this for velocity as well, which will be up here. So in the y direction, and then vy, vx, and then that should be it. But I believe things will start to float in midair if I do that. For the y values, I'm not entirely sure. And then in order to make them disappear, at least they're not floating in midair, in order to make them disappear, we can do right after this, we can say if it's less than, not less than, but it's equal to 0, then we can subtract their life by 1 each frame that they're not moving in the x or the y direction. So the x and the y direction, which we can actually just sum into one command. Plus the y acceleration. And because the acceleration is based off the velocity, as long as the acceleration is 0, that means that the velocity is not changing either. Sorry, I keep drifting off screen. Things are not disappearing. Do less than nor 9. Nope, nothing. All right. How did I do this beforehand? See, the thing is, this should work. Vx, Vy, Ax, Ay, bounce variable, lifetime. This should be working because we're setting it to 0 as long as it's within a certain range. Right there. Maybe if I reduce that value right there. And they should start to disappear. But they're not. Which is odd. Huh. Okay. Well, this should be working. I mean, these things aren't, they're not moving, right? They're moving less than a pixel. See, the thing is, if I do this, things are just gonna float and disappear. See, now things are disappearing because they're not moving because our gravity value is relatively small. But the thing is they're not even getting set to 0 even when they're below that threshold, which is concerning. Nothing's disappearing. So I'm wondering why that is. Okay. Goodness. What if we put this after the basic movement? Would that fix it? -1? No. We'll do velocity.
Girl. Love you too. Sorry.
You're good.
You were recording.
I'm just trying to figure something out.
Okay. I love you.
Love you. Odd. .0981. well, it's never going to be less than 0.0981 because of our gravity variable. So we actually need to have, okay, so I found the issue. The issue is it's applying this constantly, but not when they're not moving in on the ground. It doesn't know that it doesn't need to be applying gravity when they are not on the ground. It doesn't, or when they're on the ground. So we need to set this to be in front of this. I didn't paste that correctly. And that way, when they're not touching the ground, it can't apply gravity. Right? This should work. And then it's going to be like, oh, they're touching the ground. I don't need to apply gravity. Right? It's still not working. What the? Okay, so I know the disappearing works, but it's just not, it's not applying it yet. Okay, so what I can do instead, since this doesn't want to work, if that is less than G, we'll say G plus nor point nor 1. We'll copy this. This isn't what I did for my other one, but I don't want to reference that. I want to do this twice blind because I've done this before. It's usually not this much of a pain. It's probably just because I'm recording. So now we need to also get if their y value is within a certain range of being 700, and set it to be 700 to avoid jittering and to avoid this issue being a thing. Which means we actually don't need any of this, because that's how I did it. Okay. Equals 0. I know this is getting messy, but just bear with me a second. Even though you're not a bear. Alright. It's equal to 0. Okay. Now we need to have things say that it's equal to 0, velocity x, velocity y, and we need to set the velocity to 0. That's what it is. So I was correct in putting this before the bounce stuff got applied, so that can go back. That did not paste correctly again. And then we need to put in here velocity equal to 0. Vy equals 0. Because now we have friction being applied and we have our bounce for the acceleration. We don't need to have any velocity in the y direction once it's touching the ground. Oh dear. Well, that did not fix what I thought it was going to fix. Also, this is not correct. And I'm actually just going to redo this entire video and just multiply by this, by gravity. I'm just going to multiply gravity from now on. How about that? So where we're adding g, we're just going to multiply by g. That's why I didn't do it. Yeah. Why? Why do they get higher when they bounce? What the? What? We're multiplying by negative 0.7, so they shouldn't be bouncing higher when they come back. They should be bouncing in the opposite direction and lower. Did I forget how bouncing works? We're multiplying. What is going on? Acceleration. Maybe it has to be the velocity then. Okay, I guess it's the velocity. Or unless we have to do both. Didn't I already resolve this issue? Copy paste. Like I said, it's mostly copy paste. This is ridiculous. Oh my goodness. Yeah. Why are they bouncing higher? What? We're multiplying the velocity times negative 0.7, right? So it's not negative 0.1. It's not just bouncing back at the same velocity every time. Maybe it's the acceleration. Am I dumb, bro? It's acceleration's fault. Okay. Dude. Negative 0.7 should be small enough. Now things don't bounce at all. Okay. Negative 0.09, I guess? I don't... Okay, that's actually kind of realistic, if I'm being honest. I guess 0.7 is just too high. 0.5 keeps everything bouncing about the same rate. This is not the way it worked beforehand. I don't know what the... What? Okay. This is not the way things worked before. When I've made physics engines like this that are very simple several times. They've never done this to me before. Right. Now we need to move this up, back to the top. Because of the wonderful things that it does. Because we need to have... Because we need things to move when they're supposed to, we need to move at the very beginning and then to apply all the rules so that we get things not acting up. So this should fix things bouncing through the floor. Yes. See how nothing's bouncing through the floor anymore? We fixed that. Okay. So now we have things disappearing. Woohoo! Things are disappearing. I've set the limits correctly. I fixed it. Oh my gosh, dude. That took so long. That was like 15 minutes of me trying to do a bug fix. Anyways. Cool. Now things disappear, except the switch is still computing them because we don't have any remove function. So now things start flickering. See that? That's ugly. And now we've lost frame rate. See that? That's even uglier than the flickering. How do we get rid of this? Cool. I'm going to print on the screen how many things there are, and the way I'm going to do that, we're going to do at, I don't know, 100, 100, num. We're going to do 16 by 16 text. Oh dear. Okay. Forgot to convert it to a string. Okay, so now you can see, relatively, maybe, there's 185 things. Can I change that to 32? I'm pretty sure it only goes to 16 by 16 text. But I thought that was scalable at some point. No, it is not scalable. Wow, it didn't like that. That's not the thing I'm trying to look at. I'm trying to look at this. What is G butcher P? What? This. That is not what I'm looking at. I guess that is what I'm looking at. I don't need that. I just need it to do this at a resolution you guys can see, which I guess it's not going to do. Hopefully that's readable. On my screen it looks blurry because I don't have a screen recorder, but hopefully I'm being useful in some way or shape or fashion or form. And we have 400 things on screen and things are already not looking very pretty. How do we get rid of this? Well, let's go into that. I'm actually going to I'm going to vsync by the number of things on screen divided by our limit, which seems to be 700 from my previous one. It's all based on how many computations you have. Once you start losing frames, that's when you need to start increasing your vsync rate. So right now I have 0 or 1, and then once I get to 700, it should start vsyncing by 2 to keep things from flickering. We're going to apply this sooner. We're going to apply it at 300. So once it hits 300, it's going to vsync a little bit more so that we keep everything from flickering. Very rarely are you going to have this many particles bouncing around and stuff that you're actually going to need to be seeing, unless you're just a graphic savvy person, I guess. How do we get rid of these? So, if the, oh dear, that's not what I wanted to paste. If the lifetime of said particle is equal to 0, because we're subtracting by 1 right above it, it's equal to 0, then we need to remove it from the array. So you might need to look up how to do that in your language, because the way I was doing it beforehand, before my friend told me, hey, there's a one-line command for that, I was literally just removing everything from the beginning of the array, taking that one particle out that's dead, and then putting everything back at the beginning. And he was like, hey, you can do this in one line. And I was like, oh, didn't know that. So make sure. And then we need to remove, boop. We need to remove from this array, and I can do the number of elements to remove. So we're gonna start at px. The array, the deletion position is going to be this right here, and then we're gonna delete that many, which is the amount of information for each one. So now things should start removing. Oh dear, I actually don't know what that was. Let's run this again to see what that error is. I'm willing to bet I wrote that line incorrectly. Let's see, subscript out of range in 36. What do you mean? Oh, it's because we need to decrease. Duh, num equals num minus 1, because we're removing things on the screen now. That's our particle counter, remember? So now it should go to the correct one. Doot. Out of range at 63. Yikes. The problem with that is that shouldn't happen, because that's where we are displaying each particle. Yeah, that shouldn't happen. It's decreasing, it's decreasing. It's out of, okay, I need to display the length of of our array. Oops. Did I do that wrong? The length of the array is 104. And we have 13 times 8. Gosh, I hate consoles. Just kidding. 184. So it is correct. How many particles do we have though? Yeah, 13. That's what I thought. Okay. Okay, well, we're removing... Okay, let me think about this. We're removing the particle we're on at particle x plus, this minus 1, right? Because we don't want to get rid of the next position x. That might be the issue. Let's see. Should go to 0 without a problem, but it probably won't. At least I didn't get an error. Oh, I did. Okay. It's equal to 0. We're removing it. And then can we increase I or Oh, this is something interesting I didn't think about. What if I just, because now I have to now I have to wait for it to get back to the bottom, and the number of particles is different for the for loop. What does it do there? What is it looping to now? Right? Because the max value for a for loop is already set, isn't it? When it's running through a loop, the max value is already set, so it can't change that. This should work. I don't understand. It just doesn't want to work. It should go to 0 without an issue, but it doesn't. Well, it does. Okay. Okay. Here's an idea. Next, actually, no, we need to put this after it displays. That might be the issue, actually, is that it's trying to display something that's not there, and it's reaching for a particle that has either already been displayed or it's just dead, and it doesn't need to do that. So now maybe should go to 0 without an issue and then just not actually break. Okay. No way. Okay, I got it working. Yay! All right. I'm gonna make the particles bigger because they're kind of invisible, and I should have done this earlier. We're gonna make them 10. All right. Fairly big. Easy peasy. I say easy peasy, but I'm very annoyed. can actually, we'll take this out so that it's always displaying. Cut. The stereograph is actually kind of not difficult to explain, but it's going to take a little more time to put in than all the other stuff. Cool, so we got this working to an extent. It's not as pretty as the demonstration one. I'm just going to go ahead and add in color actually. The way I did it in the other one, I'm basing the green value off of the acceleration in the y direction, the red value is based off of the acceleration in the x direction. Times, I forgot that, times 50 for the x direction, and then times 20 for the y direction. Because the y increases faster than the x always just goes to 0. So there's that. Pretty neat. And then we could do sound if we wanted to. This probably can't be translated to other languages. If it can, that's neato. So I'm going to do a beep. I'm pretty sure 31 is the one I want to use. Okay, we don't want that happening, so we're gonna want to take out the spammy thing. And the way you do that, I'm basing the volume off of their y acceleration, so sound effect number and then pitch volume. The way I do pitch is not by drawing a line in the middle of a sound command. It's actually the x acceleration, and like I said, the volume is based off of the y acceleration, and then the panning is difficult to explain. I'm just not going to do that. Right, so now they decrease in volume if they're not hitting the ground as hard. We also need to change the pitch to be times 10 so that they actually have different variations in pitch when they hit the ground. Pretty neat. We can do 2 times the y acceleration to get more dynamics. And I'm gonna go ahead and increase the random x to 10. And then we can do this. Once you somehow have 700 on the screen, then it will, once you have 700 on the screen, then it will do VSync by 2, but it's kind of unnecessary, right? And I forgot how I did the VSync for the other one, but I'm gonna guess that I actually floored it and didn't ceiling it. Flooring rounds down, ceiling rounds up. Oh dear, we don't want that. Yeah, I guess I did do ceiling, huh? Give it to me. I really need a keyboard. But yeah, that's my far too long explanation on how I did a very simple particle engine that automatically removes things once they stop moving. So yeah, you just have to lock things to the ground at some point. There's things you can do with the buttons. I'm not going to get into that, but if anybody wants me to, I guess I will at some point. But yeah, that's how you do that. Pretty neat. Thank you for watching. This has been me doing random programming shenanigans, and I'll hopefully get to help somebody else who is interested in this sort of stuff. maybe I'll do a better produced version of this video at some point. Thank you for watching, and I'll catch you in the next video.